This will be for the Kuta Software worksheet, arcs, and chords. Okay, I will not be doing these problems in full. I will just be giving hints on each problem. So the main theorem you need to know for this worksheet: if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. All right, so in the diagram here, we can see the center of the circle right here. If a chord goes through the center, it's a diameter. So EG is a diameter. All right, EG is a diameter, and it makes a right angle with FD. So EG is perpendicular to FD. And as a result, FH right here is congruent to HD. Okay, so if a diameter is perpendicular to a chord, the chord is bisected. So this segment is congruent to that segment right there because of the right angle. Now, does the full diameter have to be drawn? No, it does not. Okay, if this part of the diameter did not exist and you just had the radius right here, all of this stuff still applies. Okay, so if you just had the radius perpendicular to a chord, the chord is still bisected. So if you see the diagram like this, the segment is emanating from the center, that's a radius, and this chord is still bisected as long as it makes a right angle or is perpendicular. All right, find the length of the segment indicated and round your answer to the nearest tenth. If necessary, that's 1 decimal. All right, let's look at number 1. See this point right here, this dot, that means it is the center. Okay, and this right here, this segment, this would be a diameter. Okay, if you drew in the whole thing, you don't have to do this. Okay, I'm just showing you. If you drew in the whole diameter here, this segment would be on the diameter, and because it makes a right angle or is perpendicular to this chord, it bisects the chord, it cuts it in half. So this is congruent to that. All right, so obviously x equals 6 because this chord here is bisected or cut in half. All right, number 2 is the same thing. This is the center right here. And if you have a radius or a segment, if you have a segment that's emanating from the center, comes from the center of the circle, makes a right angle, it bisects that chord. So this right here is congruent to that right there. Because of that right angle, this segment is bisecting that chord. Problem 3, you want to remember that the radius equals half of the diameter. Okay, and the diameter is given right here. Okay, we can see that goes through the center, so that 31.8 is your diameter. All right, you take half of that. You take half of 31.8, and that will be your radius. Okay, and also right here, I'll do it in a different color. This line segment right here is also a radius. So you just have 7 plus x. All right, so the radius also equals 7 plus x. You set this equal to that because they're both radiuses, and you just solve for x. Just set these two equal and solve for x. Number 4, light work. This is the center right here. So this line right here, this line segment, I should say, that is a radius. All right. And if you look at this line segment that contains the x, that is also a radius. So you have x plus 5.1 right here, and that equals the radius, 9.7. X plus 5.1 equals 9.7. Number 5, same thing. This is a diameter right here. All right, that's a diameter. And we know that the radius is half of the diameter. So I'll let you calculate that. And of course, this segment right here is also a radius, x plus 4.5. All right, so calculate the radius, set it equal to x plus 4.5, and solve. Number 6 is the same thing. This is the diameter right here. This right here is your diameter. Take half of that, it's going to be your radius. And this right here is also a radius, x plus 4.2. Set them equal and solve for x. Number 7, here is the center. And this line segment is emanating from the center. It makes a right angle. Therefore, this chord right here is bisected. So this segment is congruent to that segment. If this one is 10.6, this one here is also going to be 10.6. Okay, and then you can just use Pythagorean theorem. You see this right here? That's 4.3. This segment right here, that's 10.6. All right, so you're going to have to use a squared plus b squared equals c squared. Which one is your c? Well, c is always across from the right angle. So c is going to be x. All right, so if you solve for c, you solve for x. A and B, it doesn't matter which is which. You can let either A or B equal 10.6. The other one is 4.3. You just do that and solve. Number 8, same thing. This is a diameter. It makes a right angle. This chord is bisected. If this one is 8.3, then that one is 8.3 because the diagonal chord is bisected. All right, so that's 8.3 right there. And once again, use your Pythagorean theorem. A squared plus b squared equals c squared. Which one is your c? Across from the right angle. That's always your c. A and b, it doesn't matter. All right, number 9. This one's almost too easy. I don't understand this one. It's just a right triangle. Okay, so just use Pythagorean theorem. I'm assuming that that is x right there. So just use Pythagorean theorem. All right, once again, here is your radius or diameter. Makes a right angle with this chord. This chord is bisected. If this is 10.8, then this one here is also 10.8. All right, and then just use Pythagorean theorem. All right, number 11. A little bit of work or creativity is needed here. We have our x value, and we have our radius value. Okay, this right here is a radius, so I'm just going to label this equal to r. And what we have to do is draw in another radius. Okay, so if I drew in a radius from the circle to the center, it goes from the center to the circle. That is also a radius. So if r is 16.7, no matter where you draw that radius, it's going to be 16.7. All right. And let's see, we're gonna use Pythagorean theorem again. A squared plus b squared equals c squared. So which one is c? Well, of course, that's across from your right angle. The right angle is always pointing at the hypotenuse, c. Okay, it doesn't matter which one is a or b, so I'm gonna let this one equal a, and I'm gonna let this one here equal b. So use your Pythagorean theorem to solve for a. And then when you want to solve for x, you have a radius. I'll highlight it in blue. you have a radius right here. Okay, so A plus X, whatever you get for A, plus X is going to be your radius, and we said the radius equals 16.7. Okay, so once you find A, plug it in here, subtract it from both sides, and you can solve for X. Number 12, here is a radius. It makes a right angle with this chord right here. So if this piece is 12.8, this one right here is also going to be 12.8. Okay, if there's a right angle here, there's going to be a right angle here as well. So let's see. Starting from the center and going to the circle, this right here is a radius. So that's your radius R. And we just need to find this length here. This is your right angle. Across from your right angle is always the value of C. All right, so you're going to use A squared plus B squared equals C squared. So if this one is C, I'll let this side length equal B. Okay, and then I'll let this side length equal A. All right, so use Pythagorean theorem to solve for A. And then right here, you can see this is also a radius. So A plus X is going to equal 15.1. All right, A plus X is also a radius. So that equals 15.1. All right, once you solve for A, plug it in here, and then you can solve for X. Number 13 right here is your diameter. Okay, and we know that the radius is half of the diameter. So I'll let you solve that. We can see this radius makes a right angle with this chord. If this is 14.1, this one here is also 14.1. Okay, so half the diameter right here, whatever you get for half the diameter, you can do that in your head really. That's going to be your radius R, and then use Pythagorean theorem. All right, go across, and that's going to be your value for C. The other two sides are going to be A and B. All right, I'll let this side equal B, and I'll let this here equal A. Solve for A, and then you have a radius. I'll do it in a different color. You have a radius right here. A plus X is also going to be a radius. Okay? So whatever you get for your radius, plug in that length right there. That's going to be your hypotenuse C. Use Pythagorean theorem to get A, and the radius right here is A plus X. Last one, 14. This is emanating from the center. It bisects this chord. If this one's 15.7, then this one here is also 15.7. Okay, I'm going to draw in another radius because this right here is a radius R. That is 18.9. I'm going to draw in another one right here to complete the triangle. So if that radius is 18.9, this radius is also 18.9. That's going to be your C. The other two sides are A and B. If I let this one equal A, you can just do the radius right here. A plus X equals your radius. Okay, the radius is 18.9. A, you need Pythagorean theorem to solve. Plug them in and solve for X.